Hello, and welcome to this mandatory 2-hour annual refresher training on asbestos awareness. The following slides will give you a brief overview of federal asbestos requirements. The information will help protect you against worksite occupational exposures to asbestos. This information is presented to employees who work on or in buildings where asbestos is present, and to help identify and avoid risks. Let's get started. This course is designed to meet the requirements of the Environmental Protection Agency, or the EPA, and the requirements of the Occupational Safety and Health Administration, also called OSHA, for training of employees who may come in contact with asbestos-containing material while performing their job duties. The purpose of this training is to learn to identify and avoid risks of disturbing asbestos that a worker may encounter during work duties. This training is intended for employees who do not remove asbestos-containing materials as their main job function. Training of custodial, school employees, transportation, engineering, warehouse, facilities, and maintenance workers in asbestos awareness is one of the keys to a successful asbestos program at TUSD. This training is intended to give workers and supervisors the information they need to avoid disturbing asbestos or other items which may contain asbestos in the workplace. OSHA regulations requires the district to know where asbestos may be present. OSHA believes that by not disturbing asbestos, you will eliminate significant health risks for employees. In an effort to inform employees about where asbestos-containing materials are located in a building or structure, TUSD has maps that contain this information online. Further in this presentation, the online maps will be explained and shown for your convenience. Some of the federal asbestos regulatory agencies include the Asbestos Hazard Emergency Response Act, also called AHERA. AHERA is also called the Asbestos in Schools Act because it specifically applies to schools. According to AHERA, schools must conduct an inspection for asbestos materials within their buildings. Employers must also inform employees of what asbestos is and take steps to ensure asbestos in the building remains undamaged, since undamaged asbestos poses no exposure to building occupants. The National Emissions Standard for Hazardous Air Pollutants, also called NESHAP, are air emission standards set by the Environmental Protection Agency. These standards were established to manage and lower the amount of asbestos-containing materials that can be released into the air during the demolition of buildings or structures. The Occupational Safety and Health Administration, or OSHA, regulations are in place to protect workers in the asbestos industry, but OSHA regulations can also apply to general safety of all employees in the workplace or doing workplace operations. As hard as it is to believe today, at one time people called asbestos the miracle material. Not only is it a natural mineral you can dig out of the ground by the ton, asbestos is lightweight, fireproof, chemical resistant, bacteria resistant, and doesn't conduct an electrical current. Asbestos has been mined around the globe. White asbestos, which is called chrysotile, came from mines all over America. One of the mines for chrysotile was right here in Arizona. It was the small mining town of Chrysotile, Arizona. After World War II, many buildings and homes had asbestos-containing materials installed in them, and this was done because asbestos made these products perform excellently, and they were economical to make as a result of adding asbestos. Asbestos products performed so excellently and were so economical to make that in its heyday, asbestos was added to toothpaste, baby sleepwear, business suits, foot powder, body powder, theater curtains, Christmas tree skirts, and many other products, including brake shoes and clutch facings. Hollywood often used asbestos because it was easy to work with. Asbestos was used as snowflakes in movies, and they also used it in building movie sets. It was also used in the Wicked Witch's broomstick bristles in The Wizard of Oz. Asbestos manufacturers would run sales campaigns stressing the durability and safety benefits of products created with asbestos. One thing manufacturers failed to mention was the effects that the nearly indestructible mineral had on their workers' bodies. As more and more asbestos workers and users of asbestos products were getting ill from the effects of asbestos, the government in 1971 finally stepped in to begin regulating the use of asbestos in consumer products. Very strict rules were created regarding what materials could be used in the construction of a building. Asbestos is comprised of a group of natural minerals mined from the ground. Asbestos deposits are found throughout the world, but the primary sites of the commercial asbestos production are Canada, Russia, and South Africa. Commercial mining of asbestos in the United States was halted in the 1980s. Once extracted from the ground, asbestos-containing rock is crushed, ground up, and graded. This produces long, thread-like fibers of material. What appears to the naked eye as a single fiber is actually a bundle of hundreds of thousands of fibers, each of which can be divided even further into tinier fibers. Asbestos is the collective name for minerals made up of long, thin fibers that are invisible to the naked eye. Many different types of asbestos exist, and each is grouped into one of two categories, either serpentine or amphibole. The first group is serpentine. All asbestos in the serpentine group is called chrysotile. This is the most common type of asbestos found in 95% of older buildings in the United States. The second group is amphibole. The name amphibole comes from Greek meaning ambiguous. The amphibole group contains 5 types of asbestos. The first type of amphibole asbestos is amosite. Amosite is considered the second most common type of asbestos found in buildings. Amosite asbestos is also known as brown asbestos because of its color. The second type of amphibole asbestos is chrysotile, or blue asbestos, named after its color. It has been used in high-temperature insulation products and on chemical-resistant surfaces, such as laboratory tables for chemistry and biology classes. The 3 remaining types of amphibole asbestos are anthophyllite, tremolite, and actinolite. These 3 are rare and have little commercial value. They are occasionally found as contaminants or minor constituents in asbestos-containing materials. Asbestos has many characteristic properties, such as high tensile strength and resistance to fire, heat, chemicals, and electricity. These properties made it an ideal building material with many industrial uses back in the day. It can act as a binder, a thermal insulator, and a noise insulator. Asbestos has been largely used because it is plentiful, cheap, strong, and it is not flammable. Asbestos also has insulation properties to heat and electrical transfer and is resistant to chemical corrosion. The use of all of these thousands of products is where the term asbestos-containing materials comes from. Some common examples of asbestos-containing materials found in schools are flooring, vinyl base, mastic, roofing materials, ceiling panels and tiles, wallboard, joint compound, plaster, gaskets and heating and HVAC equipment, duct wrap insulation, duct joint tape, duct vibration dampening cloths, pipe and boiler insulation, fire brick for boilers, fireproofing and fire doors, acoustical spray-on soundproofing and cement pipes. The following slides are pictures of asbestos in use in buildings across the country. They are meant as examples only. Here is an example of asbestos coating pipes and some asbestos tank insulation. Here you can see some pipes that are insulated with asbestos. These pipes are located above the ceiling. Here's an example of sprayed-on pipe insulation coating made with asbestos. Here you can see some pipes that have flange gaskets made of asbestos. Here is a cloth vibration damper made from asbestos, which is located between a building duct and the fan. Caulk manufacturers often used asbestos before the 1980s as it protected against fire and heat. Common places were around the brickwork and exteriors, as you can see here. Other examples include window putties, fire doors, electrical wiring insulation, and asbestos-wrapped pipes, where the insulation around the pipes has been damaged. Here you can see an example of sheet vinyl on a counter, an asbestos-containing material which has been crumbling and could become airborne. A cove base is a molding that protects the base of walls from impact damage. Here you can see an example of an old cove base that is crumbling. The glue used to hold it to the walls is now showing, and both the glue and the cove base may contain asbestos. Here you can see an example of an exterior soffit. Note the asbestos material is crumbling and could become airborne. Here's an example of a roof with asbestos-containing materials. You may have seen surfacing applied on the exterior of a building that contains asbestos, such as here. Here you see an example of a superstructure that has asbestos applied on its surfacing. Acoustical texture of plaster-type coatings applied over wood lath, masonry, or other surfaces dates back 2,000 years. But unfortunately, starting around the early 1900s, asbestos was put into the plaster to strengthen it. Here you see an example of a suspended ceiling that has asbestos applied on its surface. You may still see this type of ceiling, even though the EPA banned such materials in 1973, with an additional ban in 1978. Some popcorn ceilings were made using asbestos. If you have it, do not disturb or damage it. Remember, the mere presence of asbestos itself does not create a health hazard unless the material is disturbed and releases fibers into the atmosphere. Asbestos fibers provided strength without adding much weight. This made it an ideal substance in gaskets, grout, tile, and other composite materials. Asbestos also provided insulating and fire-resistant properties, rendering it additionally useful in the automotive field. Asbestos fibers are so strong, durable, and virtually indestructible that they were almost used in every facility shop across the country. Friable asbestos can be crumbled, pulverized, or reduced to powder by hand pressure when dry. Non-friable asbestos cannot be manipulated in this way. Non-friable asbestos refers to asbestos that is firmly bound in any material. Non-friable asbestos is generally safer to the environment if the asbestos is left undisturbed. Therefore, non-friable asbestos poses a lower risk to your health. Undamaged non-friable asbestos should be treated as friable asbestos because any damage will make it friable. The Environmental Protection Agency, or the EPA, has divided asbestos-containing materials into 3 categories. The first EPA category is surfacing materials. Surfacing materials are interior asbestos that can be sprayed on, troweled on, or otherwise applied to surfaces like walls or ceilings for acoustical, decorative, or other purposes. This also includes blown-in materials, joint or patching compounds, and textured paints or plasters. The second EPA category is thermal system insulation. This type of insulation is used to control heat transfer or prevent condensation on pipes and pipe fittings, and other parts of hot and cold water systems, heating, ventilation, air conditioning systems, or other mechanical systems. The third EPA category is miscellaneous materials. These include materials found on structural components, structural members or fixtures, such as fire doors or vibration damping cloths. Asbestos is a practically indestructible fiber that, when breathed or swallowed, attacks the soft tissues in the body. Most rocks and minerals break down into tiny particles like grains of sand, but asbestos breaks down into fibers like strands of rope. Asbestos fibers can be so small that they are invisible to the naked eye. Inhalation is the most common route of exposure. Most exposures happen without the victim's knowledge, since asbestos fibers are mostly invisible, odorless, and tasteless. The health effects associated with asbestos exposure have been studied for many years. Results of these studies shows that breathing in asbestos fibers leads to increased risks of developing several diseases. Not all people develop these diseases after exposure, but it has been well demonstrated that most asbestos-related illnesses are dose-response related, which means that the greater the exposure to airborne asbestos fibers, the greater the risk of developing that illness. The health effects associated with asbestos fibers can lead to an increased risk of developing lung and chest area diseases. Almost daily, we are exposed to some prevailing level of asbestos fibers in buildings or experience some existing level in the outdoor air. Some fibers that are inhaled remain in the lungs. Brief bursts of exposure, when added to the background level, increase the potential to cause or trigger the development of an asbestos-related disease. These brief bursts of exposure occur in many ways. For example, when a carpenter drills a hole in an asbestos fire door without taking any precautions, an increased amount of asbestos may be released into the air. The more often these bursts of exposure occur, the greater the risk of breathing asbestos fibers. Keep in mind that everyone is exposed to asbestos at some time during their life. Low levels of asbestos are present in the air, water, and soil. Because asbestos fibers are so small, they're basically invisible. They're also so light that once stirred up, they can float in the air for a long time. This means that you can easily inhale asbestos fibers without even knowing it. And once asbestos fibers get into your lungs, they can do severe damage. People most at risk for this additional exposure are maintenance type of workers who might accidentally work on and disturb asbestos in buildings. The effects of asbestos exposure most often involve the lungs. Air breathed into the body passes through the mouth and nose, continuing into the windpipe. The windpipe divides into smaller and smaller tubes that end up in the lungs as air sacs called alveoli. It is in these air sacs that respiration occurs. Oxygen is absorbed into tiny blood vessels or capillaries, and waste gases, such as carbon dioxide, pass out of the blood and are exhaled. The body has several mechanisms to filter the air it breathes. The first filter mechanism is used for larger particles that may enter the nose or mouth. These particles get caught in the nose by the nose hairs or mucus. Items that enter the mouth are usually spit out. Cigarette smoking can mum both of these effects, disabling the first mechanism to rid the body of foreign particles. If the item is smaller and goes past the first filter mechanism, it could get caught in the second filter, the airway tubes. When an item is caught in the airway tubes, it is normally swallowed or coughed out. But if a particle is very tiny and light, it can make it all the way into the lungs and into the lung air sacs. If some particles enter the air sacs, the lungs will try to protect themselves. The tiny air sacs in the lungs will try to coat the particles. The coating will cover and digest the particles if possible. This coating of particles is very hard on the air sacs and leaves scar tissue in the lungs. If more and more asbestos fibers get into the lungs, more and more scarring will occur, which may lead to an asbestos-related health effect like asbestosis, lung cancer, mesothelioma, or other diseases related to exposure to asbestos. Asbestosis is an asbestos-related health effect characterized by lung scarring. It reduces the lungs' elasticity. When the lungs have reduced elasticity, that makes it harder to breathe and gives you shortness of breath. Asbestosis is normally seen in people who have inhaled large amounts of asbestos fibers over a long period of time. It is a serious disease, and in those persons exposed to high levels of asbestos. Symptoms can range from mild to severe and usually don't appear until many years after the continued exposure to asbestos, and it can eventually lead to disability or death. The typical latency period, or time that passes from exposure to noticing symptoms, is around 15 to 30 years. Lung cancer is an asbestos-related health effect that appears to have a dose-response relationship between asbestos exposure and lung cancer. In addition, lung cancer has a latency period before it develops, typically 30 years or longer. If you're a cigarette smoker, it's even worse. Cigarette smokers who are exposed to asbestos are over 50 times more likely to develop lung cancer than the normal, non-smoking population. Mesothelioma is an asbestos-related health effect that occurs in the chest cavity lining or the stomach lining. Cases of mesothelioma have been found in people who have had a limited exposure to asbestos fibers. The onset of this disease is related to dose and to time from first known asbestos exposure. There is no known connection to cigarette smoking with mesothelioma. Mesothelioma tends to have a long latency period, usually around 30 to 40 years. There are also several other diseases which seem to occur more often among people exposed to asbestos. Some of the more frequent diseases include cancer of the stomach, colon, and pancreas. When asbestos-containing materials are undamaged, they are not releasing asbestos fibers into the air, so there is no threat to your health. The health hazards begin when the asbestos materials are bumped, scraped, peeled, water damaged, or otherwise disturbed. Do not disturb asbestos and keep it well maintained. The EPA only requires asbestos removal to prevent significant public exposure to airborne asbestos fibers if the building is being demolished or during renovation activities. The Asbestos Hazard Emergency Response Act, otherwise known as AHERA, specifically applies to schools. It's the blueprint for keeping you and your coworkers safe. AHERA requires all public and non-public schools to have an initial inspection for asbestos and a reinspection of known or assumed asbestos at least once every 3 years. According to AHERA, many of the homes, buildings, and schools across America contain asbestos. If a school was built before the 1980s, it's likely that it contains some form of asbestos. AHERA provides guidance for schools to inspect for asbestos-containing materials in a safe and complete manner. This is broken down to 3 points of inspection. The first point, provide employees with asbestos awareness training, giving them a basic understanding of asbestos and the risks that it can be caused by asbestos. The second point, designate a contact department. And the final third point is to ensure that only trained and licensed professionals perform asbestos removal actions. As long as asbestos-containing materials remain in good condition, the Environmental Protection Agency insists asbestos poses minimum health risk and recommends schools leave it in place. But if improper maintenance work occurs, or if the asbestos is disturbed, the otherwise harmless asbestos can be released into the air. AHERA refers to a school district as a local education agency, or an LEA. The purpose of an LEA is to ensure that inspections of asbestos are conducted every 3 years and provide employees with asbestos awareness training. Also, the LEA ensures that if asbestos sampling is needed, it is only done by a licensed asbestos vendor, and the LEA coordinates the AHERA record-keeping requirements. LEAs are also responsible for designating a department which oversees asbestos management for the district. Within the LEA's designated department is normally a facilities contact person or persons known as the designated person. The designated person not only performs asbestos re-inspections and periodic surveillances, but also updates the asbestos-containing materials inventory reports. Asbestos-containing materials inventory reports are known as ACME reports. ACME reports are used to show the location of asbestos-containing materials within the school buildings or structures. The ACME reports and maps can be obtained in FAMUS. The Facilities Administration and Maintenance Information System, or FAMUS, is the maintenance management system used by TUSD to submit work order requests and allow schools to view the status of their requests. FAMUS also houses the ACME reports for the schools and the departments. Here are the steps to locate the ACME report for your school or building. The first step is to open the FAMUS Maintenance Management System and log on to the system. Click on the Asset tab near the top of the page, then click on the Find Asset tab. In the Asset Name box, type in the word Asbestos, then click on the Find tab near the bottom of the page. Scroll down to the school you're looking for, and on the left of the name of the school, you will see the blue Asbestos tab for the school you're looking for. Near the bottom of the page, under the Documentation heading, are the asbestos maps and updated ACME reports. Click on the ACME report with the most current date. Note, ACME reports are updated every 3 years, as mentioned earlier. Here's what a sample of an ACME report looks like. On the ACME report, you will see the FS map number to identify the location of the area being described. Also, the name or number of the room, the description of the area that was sampled for asbestos, the condition of the asbestos if present, and other information that may pertain to the sampled area. Before district employees start a work project, refer to the asbestos ACME reports in FAMUS to ensure an understanding of asbestos locations. Avoidance of certain activities such as sawing, sanding, and drilling asbestos-containing materials will help ensure you do not disturb asbestos. If in doubt about the asbestos ACME report information or the possibility of disturbing any asbestos-containing materials, contact the Facilities Help Desk at 225-4640. By using these practices, you can keep yourself and your coworkers safe from exposure to asbestos. Thank you for your attention to this important matter. Once again, please call 225-4640 if you have any further questions or need any more information.